let us see the voltage divider rule. So in this voltage divider rule, we can consider this circuit. So in this, two resistors are connected in series. The total voltage across this two resistors are denoted as V, and the total current flow through this circuit is denoted as I, and the two resistors are denoted as R1 and R2. Voltage across R1 is V1, voltage across R2 is V2. So two resistors are connected in series. Voltage across R1 and R2 are denoted as V1 and V2 respectively. Our supply voltage is V. So based on KVL, that is Kirchhoff's voltage law, we know V equal to V1 plus V2, so it is considered as first equation, and V equal to V1 can be replaced by I into R1 plus V2 can be replaced by I into R2. So here take outside as I, so I into R1 plus R2. So from this, I is equal to V divided by R1 plus R2. So here we can consider V equal to I into R1 plus I into R2 is second equation, and I equal to V divided by R1 plus R2 is third equation. So V1 equal to I into R1 we know very well, that is voltage across the resistor R1 is denoted as V1, which can be determined by multiplication of I into R1, which is considered in fourth equation. Now substitute third equation value in fourth equation. So V1 equal to V into R1. So third equation in fourth equation. Fourth equation is V equal to I into R1. So V1 equal to third equation value is V into R1 divided by R1 plus R2. So substitute this value. Now we find V1 equal to V into R1 divided by R1 plus R2. Similarly, V2 equal to V into R2 divided by R1 plus R2. So from this we can understand voltage across any resistance, that is Vx, which is equal to supply voltage that is V into same resistance Rx divided by total resistance RT. So here RT is equal to R1 plus R2. V is a supply voltage and total current I. R1 and R2 are two branch resistors. Corresponding voltage drops are V1 and V2. So with the help of KVL, we can able to find the voltage divider rule. So the voltage across V1 is calculated with the help of V into R1 divided by R1 plus R2, that is supply voltage V into same resistance R1 divided by total resistance R1 plus R2. Similarly, for voltage across resistance R2 is denoted as V2 equal to supply voltage V into same resistance R2 divided by total resistance R1 plus R2.